Hello guys, in this video I'm gonna continue with this example. So in this circuit here we have six floating terminals, okay? And we wanna like calculate or find the equivalent resistance, between RAD, between terminal A and the terminal D. Again, I'm saying these are floating terminals, okay? So basically they are not connected to anything. So when we use ohmmeter, which is a device that measures, the resistance of a circuit between two terminals, this ohmmeter, blocked or like closed the loop between, the floating terminals. Okay, so if you have a resistance like this, R, and you want to measure the value of R, you bring the ohmmeter, you connect it like that. So before connecting the ohmmeter, it was open circuit. These terminals was floating. Okay, they are not connected to anything, so the current is zero. But once you put or connect the ohmmeter, it's not floating or open circuit anymore. That's basically what we're gonna assume here, in this example. So when I say, that we wanna find the resistance between the terminals A and D, that means I will put an ohmmeter between these two terminals A and D, and then between A and D, it's a closed loop. It's not open. It's not floating anymore. There should be a current. Okay. So let's redraw our circuit in here, assuming that I'm gonna draw it here with dashed line, because it's something that you should imagine. Good. But still now C, B, E, and F are float, open circuit. So the current in here is zero, the current in here is zero, the current in here is zero, the current in here is also zero. So basically you can remove all these floating branches. This is something 100% correct. You can do in any circuit in which it asks for the equivalent resistance. And we end up with this sub-circuit, let's say. Okay? Good. Now let's look at the 2 ohm resistance, this one here, the 2 ohm resistance, this one here, and the 2 ohm resistance, this one here. So if there is a current floating like that, it will continue with no branching. So they have the same current. Okay, they are connecting basically in series. And hence you can just, add them together, and this will be the equivalent resistance of these 3 resistors. So basically, you can just redraw the circuit like that. Let's remove this to have some space. Again, I know that you have in your head A and D are not float. There is something between them, which is the ohmmeter. Okay, let's basically take this, copy and paste. And let's remove these 3 resistors and put just one resistor between the same terminals. Six ohm. Now, the 6 ohm and the 2 ohm are parallel to each other. So let's find out the equivalent resistance of both. So we're gonna use this website that I teach you before. Let me bring it here. So we have here the website. So you define here the number of resistors, you define the first value, define the second value, click calculate. So the equivalent resistance, parallel resistance, is 1.5 ohms. So what I'm gonna do I'm gonna just, continue in here. I will just remove this. There is no space. So, and this will be 1.5 ohms. Okay? And that's it, guys. Now, between A and D, there are three resistors. Okay? All are in series. 2 ohm, 1.5 ohm, and 2 ohm. So R AC is equal to 2 plus 1.5 plus 1 plus 2, I'm sorry. So that's basically 5.5 ohms. Very easy, very simple. Okay? Okay, let's have another example based again on the same circuit. Now, let's find out the resistance between A and F. This is terminal A here. This is terminal F here. Okay? We want the resistance between these two terminals. Again, if you have an ohmmeter and you want to find the equivalent resistance or the resistance between two terminals, then between these two terminals, it will be a closed loop. So let me redraw here to make you imagine the situation after connecting the ohmmeter in dashed line here. So between A and F, it's not open anymore. But still, the other terminals B, C, D, E are float, so open circuit. They are not connected to anything. B is not connected to anything. So there is no current here. It is zero. So zero here, zero here, zero here, zero here. So you can just remove these float branches. So I'm gonna remove C. I'm gonna remove D. I'm gonna remove E. And I'm gonna remove B. Fine. And we end up with this resistor. We don't want RAB. Actually, we want RAF. I'm sorry. This is because of the copy and paste. Okay. So you end up with this beautiful circuit. You have the 2 ohm and the 2 ohm in series. Why? Because they have the same current and connecting or common in one terminal. This current have nowhere to go except going up. And you have these 2 ohm now, and this 2 ohm are in series also, because if they have a current, this current has nowhere to go except to continue downward in the other resistance. Okay? So we have here 4 ohms, and we have also here 4 ohms. The addition of these two resistance. Okay? So let me redraw this. So we have here 4 ohms and also here 4 ohms. And now this 4 ohm and this 4 ohm are in parallel. Why? Because they are common in the top terminal and common also, or they have the same bottom terminal, same terminal. So they are in parallel. So basically, we can remove. So 4 parallel with 4. These are two resistors have the same value. So the equivalent resistance is 4 over 2. Just take one and divide by the number of resistors in parallel if they have the same value. And you can use also the website if you are confused. So this will be 2 ohms. So the equivalent resistors is 2 ohms. So I'm gonna again remove that. So the equivalent resistance will be 2 ohm here. And look now, between A and F, there are 3 resistors, this one, and this one, and all in series. Why? Again, if there is a current floating like that, there is nowhere to go except to continue in all the resistors. Okay? And again, one might say, oh, A is float, it's open. F is float, it's open, so there is no current. There should be no. Remember this one. You have to imagine there is an ohmmeter between A and F. An ohmmeter is the device that measures the resistor or the resistance. So if we basically redraw the ohmmeter here between A and F, and I'm drawing it in a dashed font because basically it's not part of the original circuit, So now, yeah, there might be a current. It's okay. Because the ohmmeter has like a voltage source inside. So it can produce current. Okay, so this is a closed loop. So basically now R AF is equal to 2 plus 2 plus 2 equal to 6 ohms. Okay, guys, that was it. Thank you very much for watching. See you in another video. Bye-bye.